Do you want to see how we built up our new digital control board? Firstly, we use a metal stencil to screen print solder paste onto the correct places on the circuit board for the various components. Solder paste contains tiny balls of solder held in a liquid flux. When heated correctly, the solder melts. Commercial manufacturers use automated pick-and-place machines to place the components onto the PCB. However, we are just building the first prototype, so we are placing components manually using tweezers. The components are tiny, so we use a microscope to make sure they are in the right place. It is slow work. Here is the board with all the components placed and ready for reflow. We are lucky to have a vapour phase chamber, which we can use to reflow the board. This uses a liquid called galden, which is heated in the chamber to create a vapour at just the right temperature to cause the solder to melt. This technique ensures an even application of temperature over the board. When the reflow cycle is complete, the chamber cools itself, and then the finished PCB can be raised up, removed, and taken for initial power-up testing. The galden liquid is an inert substance, but we don't leave the lid of the chamber open for long as it is very expensive. So the board is ready now for electrical tests. We first apply power from a current limited bench supply and check all system voltages are correct. We then connect a JTAG programmer to the board and see if we can communicate with the microcontroller. And yes, there we go. We have successful communications to the microcontroller from the software development environment. This is a great start. With communications to the microcontroller working, we can begin developing simple applications to test out the rest of the hardware on the new board. In the example here, we are programming Flash with a simple program to light up our 6 status LEDs in sequence. With that working, we can now move on to develop code to bring up the UART and CAN bus communications, operate multiple PWMs, and measure parameters using the 16-bit ADCs. Thanks for watching. It's always exciting to bring new designs to life.